Hello students, I am Kausalya. Today we are going to solve example 1.8 in control systems. So the problem is write the differential equations governing the mechanical system shown in figure. Draw the force voltage and force current electrical analogous circuits and verify by writing mesh and node equations. This problem is quite bigger. So I have splitted this problem into part 1 and part 2. So now we are going to see part 1. So this is the given mechanical system, and this mechanical system consists of two masses M1 and M2. So the first step is we have to draw the free body diagram of mass M1 and mass M2. So to draw the free body diagram, just count the number of elements which are connected to mass M1. So here in this case we are having force 1, 2, 3, 4. Right. So totally there are 4 elements which are connected to mass M1. So apart from that, this mass M1 will produce one force. Right. So totally 4 plus 1, 5 forces. That is 1, 2, 3, 4. And apart from these 4 forces, one opposing force will be produced by mass M1. So while drawing the free body diagram, this mass M1 we are having a directly applied force F of t. So here I have drawn F of t as such. So now we are going to draw the opposing forces. So here the opposing forces are, one is by K1. So first let me draw F K1 and another force by B12. So F B12 and another force by F B1. So F B1 and another force by this mass M1 itself. So opposing force produced by mass M1 is given by F M1. Right. Now we are going to write the respective equations for each and every term here. So the first one is Fk1. So Fk1 will be directly proportional to the displacement. So here again this K1 is connected between M1 and M2. And the respective displacement of M1 is x1 and for M2 it is x2. Here we are considering only mass M1. So the initial displacement of mass M1 should be considered. So we have to write K1 is, that is K1, force produced by K1 is nothing but x1 minus x2. So Fk1 is directly proportional to x1 minus x2. So when include proportionality constant, that becomes K1 into x1 minus x2. And the next one is Fb12, and again this B12 is connected between M1 and M2. So while writing the expression, we have to write it as d by dt of x1 minus x2. Right. When you include proportionality constant, this becomes B12 into d by dt of x1 minus x2. And the third one is Fb1. So this B1 is connected only with mass M1. So this can be represented as Fb1 is directly proportional to dx1 by dt. So when you include proportionality constant, that becomes B1 into dx1 by dt. And the last one is Fm1. So this can be written as Fm1 is directly proportional to the acceleration. So here the displacement is x1. So d square x1 by dt square, which is nothing but m1 into d square x1 by dt square. Right. Now we are going to apply our Newton's second law. So by Newton's second law, here the applied force is F of t. So this F of t is equal to sum of opposing forces. So here the opposing forces are Fk1 plus Fb12 plus Fb1 again plus Fm1. Right. Write down the respective expressions here. So when you write here, you will be getting K1 into x1 minus x2 plus B12 into d by dt of x1 minus x2 plus B1 into dx1 by dt. Again the last term will be m1 into d square x1 divided by dt square. Right. This is our expression. So this is the first differential equation. So name it as equation number 1. Now I am going to rewrite this equation in terms of velocity. Here the entire expression is in terms of displacement. See, x1 and x2 in each and every term. Now I am going to rewrite this displacement in terms of velocity. So we should know the basic formulas. So here x can be written as integral of v into dt, right? And dx by dt can be written as velocity. And finally d square x by dt square can be written as dv by dt, right? Just consider these terms and we have to replace the above expression in terms of velocity. So here we will be having f of t is equal to k1 into, say in terms of x we have to write integral of v dt. So here we are having x1 minus x2, so we have to write v1 minus v2 into dt plus b12 into here d by dt. So d by dt is nothing but velocity. So here just write it as v1 minus v2. And the next one is here b1 into again dx by dt is represented as v. So dx1 by dt is written as v1. And the last one is m1. So m1 into, so d square x by dt square can be written as dv by dt, right? So here I am writing it as dv1 by dt. Clear? So this is the differential equation in terms of velocity. Okay, just name this equation as equation number A, right? Now the second one is we are going to draw the free body diagram of mass m2. So again consider the problem. So in this problem just count the number of elements which are connected to m2. So totally 1, 2, 3 and 4. 4 elements are connected. So we will be having 5 forces totally. There is no direct applied force on mass m2. So the applied force on mass m2 is 0. There are only opposing forces. So the opposing forces are listed down as Fm2, Fk2, Fb2, Fk1 and finally Fb12, right? You see, opposing force produced by mass m2, Fm2, and here we are having K2. So opposing force will be produced by this K2. So Fk2, Fb2, Fk1 and Fb12. Okay, I had drawn totally 5 opposing forces here. Just now write down the expression. So when you write, and the respective displacement of m2 is given as x2, right? So when you write Fm2 is directly proportional to d square x2 by dt square. So when you include proportionality constant, that becomes m2 into d square x2 by dt square. The next one is Fk2. So this Fk2 is only connected with, this K2 is connected with only mass m2. So we can write Fk2 is directly proportional to x2. So when you include proportionality constant, that becomes K2 into x2. And the next one is Fb2. So here again this b2 is connected only with mass m2. So this can be written as dx2 by d2, which is nothing but b2 into dx2 by dt, right? And the next one is Fk1. So again this K1 is connected between masses m1 and m2, and now we are drawing the free body diagram of mass m2. So the initial displacement of m2 is x2. So we have to write x2 minus x1, right? So here Fk1 is directly proportional to x2 minus x1, which is equal to K1 into x2 minus x1. And the next one is Fb12, and again this B12 is connected between m1 and m2. As we are drawing free body diagram of mass m2, we have to write x2 minus of x1 while writing the equation. So Fb12 is directly proportional to d by dt of x2 minus x1, which can be written as B12 into d by dt of x2 minus x1. Right. Now again by Newton's second law, we are writing There is no applied force here. So applied force is 0, which is equal to sum of opposing forces Fm2, Fk2, Fb2, Fk1 plus Fb12. So just substitute the respective values. Here you will be having m2 into d square x2 by dt square plus k2 x2 plus b2 into dx2 by dt plus fk1 is k1 into x2 minus x1 plus finally b12 into d by dt of x2 minus x1. Right. This is our respective differential equation for your mass m2. Now again I am going to rewrite this equation in terms of velocity. So just let me refresh. So x is equal to v into dt and v is nothing can be, it is dx by dt, and finally d square x by dt square can be written as dv by dt. So again I am going to substitute these values in the above equation. Let this be equation number 2. So while substituting we will be having 0 is equal to m2 into, so d square x by dt square is nothing but dv by dt. So dv by dt, here we are having 2, so I am writing dv2 by dt. Plus again k2, x can be represented as integral of v into dt. So since it is x2, here we are writing it as v2 into dt. Plus again b2, so it is represented as b2 into v2. Plus again k1 is represented as v2 minus v1 into dt. Plus finally b12 into d by dt. So dx by dt is velocity. So here it is represented as v2 minus v1. Right. Hope you all have understand what we have done today. The nothing but we are drawing the free body diagram and we are counting the number of elements which are connected to the respective masses, and we are writing the force balance equations, and finally by applying Newton's law we are writing the differential equation governing the systems, and this differential equation is in terms of displacement, that is in terms of x. So here I am replacing x in terms of velocity. So this is our final expression B. Right. So only one part of the problem is solved here. So now we have solved the differential equations governing the mechanical system. The rest that is force, voltage and force current we will see in the next video. Thank you.